Hello and welcome back to Calculus 1. Now we are going to talk about mean value theorem. The word mean as a medium, as the middle, not as evil. Okay? So let's first understand the concept. So here we have the car. Going on a road that is 65 miles per hour speed limit. We all know there's a lot of shrubbery along the roads. And then, once in a while, which is every day, we have another car that has Christmas lights on it. There we go. Now, in this scenario, since I'm going to put 5 miles distance between these two locations, and we'll put another one over here with Christmas lights as well. There we go. So these two speed traps measuring with, let's say, X band or whatever, monitoring the speed along the route. Now, obviously, what you did is you invested $400 into one of those radar detectors. So, as you were going through the first trap, you went exactly 65 miles per hour. You were not pulled over, nothing special, right? At 3:09 p.m. And then you drove, and then when you were getting close to the second trap, your radar detector got tripped off again, right? So you go to the second at 65 miles per hour at 3:13 p.m. and you were not pulled over because you went exactly the speed limit, right? That's fine, not an issue. And a few days later, in the mail, you got a ticket for speeding. What? I know, right? So let's talk calculus. Now, this class currently, doesn't have enough students. I mean, chances are there. No one already self-identified, so I said probably not enough of you. But in my other Calc 1 class, when I taught this, already one person said, yes. What happened? So here's what happened. Let's calculate the average speed, right? What do I have? What do I know? Well, average speed, velocity, is distance over time. We see that our distance is 5 miles, and our time is 4 minutes. Now, I need to move my minutes into hours, because we want miles per hour. So we will multiply in denominator 1 hour over 60 minutes, so that minutes can cancel, which would leave hour as a unit. So I have 5 times 60 when you solve the double fraction divided by 4, and now that's in miles per hour. Great. So now my average velocity is going to be I cancel these guys, I get 15. 5 times 15 is 75 miles per hour. Great. 75 miles per hour average speed, and we went through both of these traps at 65. Do we see that the actual speed in between these two had to be well over 75 miles per hour so that it can average down to 75 miles per hour? Does that make sense? Does it even make sense to have 85 miles per hour? Because if you know that on the low end you went 65, on the average you went 75, then what averages to 75? Well, clearly 85, and 65 would average to 75. Does it make sense? But your ticket was exactly on 75 in mail. Huh? Yeah. See, that's the calculation. So we calculated average velocity, and the theorem that we are learning now, called mean value theorem, is the theorem that says that if the function is continuous, well, you didn't teleport anywhere, and if the function is differentiable, well, you do have a velocity, right? Then at least at one point your average is the same as your instantaneous. And instantaneous is the one that you're ticketed for. Instantaneous is your speedometer that changes instantly as you touch gas or a brake, right? And that's what you, so as you are driving, if you see a cop car behind you, you immediately look at your speed, right? That's like the reflex. I see we have some professionals over there with the situation. I had one student in my other class. She was driving 90 on 55. That's 5 points and $400 to begin with. Let's not talk about the insurance and other things that yeah. So yeah, there you go. So the theorem now is going to state, because you can only be ticketed for instantaneous, not for the average, the theorem says that your instantaneous and your average will be the same, at least at one point in time, if you have function that it's continuous and the functions that's differentiable. So now, since, as I said, it's a continuous road, you don't get to teleport yet. You don't get, well, then speeding is not even necessary if you can just teleport to classroom and teleport back home. There is no, procedure of being on the road. So going from one point to another through the continuous function, and then also having the differentiable function right there, that's all great. Conditions are met, so that means that your instantaneous velocity was at least once the same as your average velocity, and they can, since they know what your average velocity is, they can immediately ticket you for instantaneous 75. Now we all know that you went more than 75, but since the average is 75, and that's the one that we can prove through the theorem, that's the ticket that is being sent out. Do we actually need squad cars for this? No. How is this implemented? Yeah, I can think of that, but easy pass. Right? From gate 1 easy pass to the gate 2, there is a exactly set amount of miles. You have speed limit of 65, there is the exact time. Now we have to have a squad car, because what you can do, you can drive 120 between two easy pass gates, and then before you pass the second one, you park on the shoulder and you wait 3 minutes until it, the time goes on, and then you pass through, right? There's a possibility. So they have to still make sure that no one is doing that, right? Obviously, if you drive 120 between two easy pass gates, you will be ticketed for 120. Will you get ticketed? I don't know. It depends. The Texas or here, I guess. I don't know. Anyway, so yeah, that's that. Let's take a look at the theorem, do another problem, and we're done. So, what's the mean value theorem? If function is continuous on closed interval, a, b, and differentiable on open interval a, b, then there is at least one point C in that interval AB such that, and now we have f of b minus f of a over b minus a, this is your standard average, is the derivative, which is instantaneous, at C. You have two conditions, continuity and differentiability, and you have the formula as what calculates things. So let's do two examples. One example is going to be just a vanilla calculation, and another example we can use something that it's like a word problem. So mean value theorem for problem 30. So we have f of x is equal to x plus 1 over x on interval 1 to 3. We are looking for value c at which all of this works. Now, first off, immediately you say, not continuous. We have the vertical asymptote at 0. Sure, yes, you do, but 0 is not in your interval, so hold on, right? It says continuous on the interval. And if you remember the lecture on continuity, I said we worry about piecewise continuity as well. We want just the continuity on the piece of the function that we are interested in. And right now we're only interested in a piece between 1 and 3. So is x continuous from 1 to 3? Yes, x is continuous anywhere from negative infinity to positive infinity. Is 1 over x continuous from 1 to 3? The answer is yes. The only discontinuity that 1 over x has is at 0, but 0 is not in our interval here. The way to break this theorem is to put negative 1 to 3. Negative 1 to 3 would involve vertical asymptote. The function is discontinuous there, and then the conditions for our mean value theorems fail, so the answer you get is going to be wrong. But in this case, it's actually from 1 to 3, so both of the functions, x and 1 over x, are continuous on interval 1 to 3, so everything is good. We can differentiate this, so it's differentiable everywhere. We get 1 minus 1 over x squared, so it's differentiable, as you can see. And it's continuous. We already talked about it. So differentiability check, and continuity check. So conditions are filled. Well, let's plug everything in the formula. So f of b, well, that's going to be f of 3 minus f of 1 divided by 3 minus 1. That's the left-hand side. That's the average. Yeah, we'll have to compute it, but that's it. On the other side, we have 1 minus 1 over c squared. The derivative of c, not derivative of x, the derivative of c, so x is replaced with c. So now, f of 3, well, that's 3 plus 1 over 3. Then we have minus 1 plus 1 over 1. So all I did is I took the original function, and I took my 1 and 3, and plugged them where they belong. So function computed at 3. All of this divided by 2. 3 minus 1 is 2. Equal to 1 minus 1 over c squared. So this is 10/3 minus 2 divided by 2. That's 4/3 divided by 2 is 2/3. 1 minus 1 over c squared. Move 1 over c squared to the left, and then have 1 minus 2/3 on the right, which is 1/3. So we have 1 over c squared is equal to 1 over 3. And to solve this equation, you can either cross multiply, or you can use the older trick in a book, which is if you flip fraction on one side, you flip fraction on the other side. And c is equal to plus minus square root of 3. There it is. So for these two values, oh, sorry, negative 3 is not in our, so we only have c equals square root of 3. That's it, that's the only one. Negative, why am I writing negative? I can just say negative root 3 not in 1 to 3. Remember that we have the restricted domain. So our calculation came up with two values, and one of those values was not in the interval that we were considering, so throw that in the garbage. So at c equals square root of 3, we have the average and instantaneous values to be the same. Let's see. Usually I look at problem 45. There are two police problems, which is what I did as the introductory problem, so you can consider that as well. Running pace 45. Explain why, if a runner completes 6.2 mile race in 32 minutes, then he must have been running at exactly 11 miles per hour at least twice in a race. Ran 11 miles per hour at least twice. Why? Well, this is exactly the same as our introductory police problem. You have your average velocity, which is distance over time. Distance is 6.2 miles, and time is 32 minutes, which you want to convert to hours. So 1 hour has 60 minutes. So minutes and minutes will cancel, and we'll have 6.2 times 60 divided by 32. So velocity average is equal to what? Well, we have 6.2 times 60 divided by 32 to give us 11.625 miles per hour. So we see that the runner reached an average of 11.6 miles per hour, but we know that when the runner starts, so this is the race in time, and this is runner's velocity in time. We know that the runner's velocity was 0 at the start. I don't care what happened here. Eventually, this is the end, and the velocity is 0 again. So somewhere is an average of 11.625. So the runner was running faster than 11.625. Maybe even up to 20 miles per hour. I don't know. But the trick is that you can see that at least once or twice, right? Because you have to surpass the average and then go back through average to go to 0. The same thing with your car, right? You're not jumping in through the window in moving vehicle when you're leaving your home. The car is parked in your driveway, right? You unlock the car and you sit in the car and then you start the car. Well, no. First you inspect the car, you walk around the car once, then you go unlock, go in, then you put the seatbelt on, and then you start the car. That's the proper procedure. Good. Ta-da. Bye.